Hi, welcome to another lesson with Dr. Hill. Today we're going to be talking about scale. And the reason we're talking about scale is because I have a class, and what we're doing is we're building a scale model of the solar system, because it's really hard to appreciate just how big the solar system is without building a model. You can look at all the pictures you like, but you never get a true appreciation of just how vast these objects are, some of them compared to our planet, and just how vast the distances are. So in order to start that discussion, we've written down a table of the dimensions of the solar system, the diameter of the various objects, the distances between the various planets and the star, our sun. And now what we want to do is we want to choose a scale to build our model at. And so what we need to do is we need to introduce scale and what it actually means. Now, what is scale? Well, scale is an exact relationship, an exact ratio between a plan or a model or a map and real life. So on the one hand you have, say, a distance on a map, and on the other hand you have what that means in real life. And they're actually relatively simple to understand once you get the hang of them, but they look a bit complicated initially. So let's take a couple of examples. For example, here I've got this this model boat that I'm building. This is made out of cardboard. It's rather fun. Don't know if I'll ever get it finished. Who knows? I just wanted to play with it with cardboard to see if it was going to work. But this model is built at a scale of 1 to 96. So what does that mean exactly? Well, what it means is that 1 centimeter on this model, if I measure 1 centimeter across the model, which is maybe about that far, then that represents 96 centimeters in real life. So this scale boat, so if I measure that distance there and find it's about 15 centimeters, that means it's going to be 15 times 96 centimeters from there to there in real life on this real life boat, which doesn't exist anymore. These boats have all rotted away and died. All we have is the plans, so we can build scale boats from the plans. Here's another example. This is at exactly the same scale. It's just a little rowing boat. Look at that. It's kind of fun. Again, made out of cardboard. This one's nearly pretty much finished. And again, it's 1 to 96 scale. And so 1 centimeter on this model represents 96 centimeters in real life. So what we can do is we can just measure this. It's a bit easier to measure this one than it was to measure that one with a ruler, and I measure that at 6 centimeters. So the actual size of this boat would be 6 times 96 centimeters, which is going to be a little around 5.5 meters, something like that. So why 1 to 96? Well, it's kind of old-fashioned scales. Were always kind of divisible by 2 and 4 and stuff. So 96 is a good number that's divisible by lots of other numbers. So you can scale down in whole numbers quite nicely. But don't worry about that. Maps and things will have scales of maybe 1 to 100,000 or 1 to 200,000, something like that, which are completely decimal, and you don't have to worry about things like 96. Let's have another look. So let's have a look at the board, and we'll see what we've got on there. There's my wee boat, and we'll see exactly how that's going to work. So let's just go through the notes. Scale is a ratio. Nice and simple. It's a ratio. It's a relationship between a plan on one side, or a model, or a map, and real life. What that represents in real life. Okay. Normally it represents distance. There are some scales that will do other things, but generally distance. And here's an example, 1 to 96. That's this little boat here, 1 to 96. Now we measured that at, what was it we measured it at? Let's get my ruler out. And I need to find my centimeters. There they are. And that was 6 centimeters. So the boat was 6 centimeters. So that boat is 1 to 96. So if I measure 6 centimeters on the model, it's going to represent 96 times 6 centimeters in real life. So it's going to be 6 times 96. So 6 times 96 centimeters, which is going to equal, and we'll get the calculator out, on, and 6 times 96 equals 5.76 meters. It's 576 centimeters. My calculator has turned it into meters for me. So 5.76 meters. Okay, so that's nice and straightforward. And you can take all sorts of examples. This little dude here is a toy soldier, plastic thing that I found lying around the house. And he's at 1:76 scale. We have a map. Here, I'll need to show you the map on the with me over here. So we have a map of Orkney. And if I want to navigate across Orkney, I need to know how far things are apart so that I can figure out how long it's going to take me to get from one place to the other. And the scale on this map is 1 to 50,000. So if I'm going to walk a distance of 5 centimeters on the map, it's going to be 5 times 50,000 centimeters. Okay, and then I can convert back to meters and kilometers. So a scale is a ratio, and it will always have a 1 representing what's on the model, or what's on the map, or what's on the plan. 1. And it will tell you how many of that you will have in real life for your scale. So you can have a scale of 1 to 96 for my model boat, for example. 1 to 96. If we could try and figure out how long that boat is. I don't know exactly how long that thing is. 60 centimeters long, perhaps. 1 on the model, or the plan, or the map will equal whatever the scale is in real life. 96 for the boat, 50,000 for the map, 76 for the wee dude here, and that's it. So what we're going to do in our next lesson is we're going to try and figure out a scale that we can build our model of the solar system with. And it's going to be a scale that is going to allow us to see the smallest planet, which we're not counting Pluto, so we're talking about Mercury here. We're going to be able to see the smallest planet. That means it's going to have to be this little. But we're also going to see the full distance at the same scale of the furthest planet from the Sun to the Sun. So that's going to be interesting, and we'll see how we're going to calculate that in the next lesson. So I hope you enjoyed that. Any questions, pop them down below, and I will see you in the next lesson.